Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with orthographic front view and top view projections corresponding to an engineering object, and using the information available with us through these two orthographic projections, we are required to obtain the 3D isometric projections corresponding to this object, into which the front view face, the right hand side view face and the top view face of this object will be represented into a single 3D isometric projection. So in order to obtain the isometric projections of this engineering object, we need to obtain the dimensions of this front view face, the right hand side view face and the top view face corresponding to this object. So as we look into the orthographic front view projections, we observe that the length of the object happens to be 100 millimeter and the height of the object, it is equal to 40 millimeter. So the front view face of this object will be obtained in the 3D isometric projections into the XY orientation over here. So here we have got isometric x-axis, alongside which we are going to represent the length of the object. Here we have got the isometric y-axis, alongside which we are going to present the height of the object. Similarly, as we observe this object from the top view projections, the length of the object happens to be 100 millimeter. The width of the object happens to be 100 millimeter. So the top view projections will be obtained into the XZ plane over here. Alongside isometric x-axis, the length will be projected. Alongside isometric z-axis, the width of the object will be projected over here. Similarly, the right hand side face, it will be mirroring. Width is equal to 100 millimeter and height, it is equal to 40 millimeter. So the right hand side face will be projected alongside YZ plane over here. Alongside y-axis, we are going to project the height of the object. Alongside the isometric z-axis, we are going to project the width of the object over here. So this way, now using the information available with us through these two orthographic projections, we have to first of all convert all the true length dimensions which are available with us into the orthographic projections into the isometric length dimensions over here. So all the true length dimensions, they have to be plotted alongside this true length scale, and then using this vertical projections from the true length scale onto the isometric length scale, we will be able to obtain the corresponding isometric lengths corresponding to the different dimensions which are available with us into the orthographic projections over here. Now let us proceed with evaluation of the isometric projections corresponding to this engineering object. So as discussed, first of all, whatever dimensions they are available with us into the orthographic projections, so they will be plotted alongside true length scale over here, and the corresponding isometric length dimensions we are going to evaluate over here. Now in order to start with evaluation of the isometric projections, so from the center point, here we have drawn the isometric x-axis at an inclination of 30 degree with respect to the ground. We have projected isometric z-axis at an inclination of 30 degree with respect to the ground over here towards the right hand side. So the height of the object will be projected alongside y-axis over here. Now we know that into the front view, we have got 100 millimeter, it is equal to the length of the object. So 100 millimeter length of the object we have projected alongside x-axis over here. We know that the height of the object is equal to 40 millimeter. But here we have plotted to begin with 20 millimeter only. Why? Because now we can observe that this object can be divided into two elements over here. So there is a bottom horizontal web which is having its four corners which are going to be inclined from the bottom of this particular web over here. So here we have got a bottom horizontal web into which the four corners, they are going to be inclined and it is going to have a central circular hole over here. Similarly, there is a top surface web which is going to measure 60 millimeter square, and this is going to be a vertical square web over here. And again, into this top web we are going to have a circular hole having 40 millimeter. So to begin with, we are going to start with construction of the bottom web which is going to have dimensions 100 millimeter square over here. So now, corresponding to element number 1, length we have plotted alongside the isometric x-axis, width we have plotted alongside the isometric z-axis over here. So now we know that the base of this bottom web we have been able to obtain over here. Once we draw another isometric projection line measuring 100 millimeter parallel to the z-axis, and one more isometric projection line which is going to measure 100 millimeter parallel to the x-axis over here. So now we know that the height of the base web, it happens to be equal to 20 millimeter. Let us complete the front view face over here. So into the front view face, we are going to see that height, it will be 20 millimeter and the length is going to be 100 millimeter. So once we draw another isometric projection line starting from this point measuring 100 millimeter parallel to the x-axis, and one more isometric projection line we have drawn starting from this point measuring 20 millimeter and parallel to the y-axis. So the front face of the lower portion of the web we have been able to obtain over here. Similarly, we draw another two isometric projection lines over here. So this isometric projection line, it measures 100 millimeter and it is parallel to the z-axis. Another isometric projection line we have drawn from this point measuring 20 millimeter parallel to the y-axis. Now, the right hand side view face corresponding to this lower web, it has been obtained over here. And if we draw another two isometric projection lines, one isometric projection line measuring 100 millimeter parallel to the z-axis, another isometric projection line measuring 100 millimeter parallel to the x-axis. Then the isometric projections corresponding to the top face of the lower horizontal web measuring 100 millimeter by 100 millimeter, they have been obtained over here. So having obtained the isometric projections corresponding to the bottom web, now let us proceed to evaluate element number 2 over here. Now this element number 2, what are the dimensions of the element number 2 available with us? It is a square measuring 60 millimeter, edge size and height is equal to 20 millimeter. So how this element number 2 can be located centrally on top of this lower web? So now we know that the top face of this lower web, it is going to measure 100 millimeter by 100 millimeter. So we'll measure the center points corresponding to the two perpendicular edges of the square face over here, and once we join this point and this point, so the axis point alongside the z-axis will be obtained, and once we measure midpoint of this edge and midpoint of this edge and we join these two midpoints, so another axis line or the center line will be able to obtain parallel to the x-axis over here. So wherever these two center lines, they are going to intersect with each other, so the center of symmetry corresponding to this element number 2 can be located over here. So now we know that the dimensions of the upper web which is available with us measuring 60 millimeter by 60 millimeter cross section and height is equal to 20 millimeter. So it has to be located over here. So the upper horizontal web has to be obtained centrally on top of the lower web. So now from the center points, we'll measure the distance 30 millimeter towards left side, 30 millimeter towards the right side. So distance between these two projector lines will be equal to 60 millimeter. Similarly, onto this side also 30 millimeter on the rear side and 30 millimeter onto the front side. So two projector lines we have drawn corresponding to the center of symmetry available over here. So now distance between these two projector lines, it also happens to be equal to 60 millimeter. So now we have been able to obtain the square projections corresponding to the base of the second element, which is our upper horizontal web over here. So we know that the height of this second element happens to be equal to 20 millimeter. So now we are going to mark this height is equal to 20 millimeter. So from corner number 1, corner number 2, corner number 3 and corner point 4. We have to draw 4 vertical projector lines over here parallel to the y-axis in such a way that the isometric height corresponding to these 4 vertical projectors will be equal to 20 millimeter each. So now once we obtain the height of the upper web, now we can join 4 edges corresponding to this particular top surface of the upper horizontal web over here. So this way element number 1 has been located, element number 2 has been located, element number 1 measures 100 millimeter by 100 millimeter by 20 millimeter. The element number 2 measures 60 millimeter by 60 millimeter by 20 millimeter over here. So now another information we have with us, both these webs, they are carrying a central hole through and through available with us at the center, having diameter is equal to 40 millimeter. So now corresponding to the top surface of the second web, again we are going to find out the center of this top surface web. So this was 60, so this distance is 30, this was 60, this distance is also 30. So we have already measured the midpoints of the two edges which are available over here. Similarly, the midpoint of these two mutually perpendicular edges, they have also been located over here. So the center point of the top surface of the second element, it has been observed over here. Now with this as center, we are required to obtain a circular hole at the top, but we cannot draw a circular hole straight away because we know that a circle is going to be projected as an ellipse into an isometric projection over here. So how this ellipse will be obtained over here onto the top surface corresponding to the circular hole bearing 40 millimeter. So now here with respect to these two center lines over here, now we are going to draw 2 projector lines which are on either side of these two center lines, such that we are going to obtain a square projection over here corresponding to this center of symmetry line. One projector line we have drawn on the left hand side of this particular projector at a distance of 20 millimeter. Another projector line with black color we have marked over here onto the right hand side of this center line. So this distance will be equal to 40 millimeter. Similarly, corresponding to this center of symmetry line, onto the left side we have marked a projector line at a distance of 20 millimeter. Onto the right side of the center of symmetry line, we have marked a projector line at a distance of 20 millimeter. So this way we have been able to obtain a square projection into the isometric projections over here, such that the edge length of the square will be equal to 40 millimeter. And we know that a square is represented as a rhombus in isometric projections over here. So we can see into this rhombus construction, which is corresponding to the square of edge 40 which we have obtained into the isometric projections. This is the minor diagonal of this rhombus. This is the major diagonal of this rhombus. So now we are going to make use of 4 center method in order to obtain the circular projections which will be represented as an ellipse into the isometric projections over here. So how do we obtain an elliptical projection over here? From the two ends of the minor diagonal, we are going to join the midpoint of the opposite two edges over here. So we can check from this corner of the minor diagonal. We are going to draw one projector line in this direction such that it is going to intersect with midpoint of the opposite edge of this particular square over here. Similarly, from this corner of the minor diagonal, again another projector we have drawn such that it is going to intersect with midpoint of the opposite edge over here. Similarly, from the other side of this minor diagonal, once again these are two opposite edges from this particular corner. So from this particular corner, we are going to join this midpoint of the opposite edge. From this corner, we are going to join this midpoint of the opposite edge over here. So again, two projectors we have been able to obtain. And now 4 centers we have been able to obtain, through which if we draw 4 circular arcs, we will be able to obtain the elliptical projection into the isometric projections, which is going to represent the circular hole in the isometric projection. So what we have to do, we are going to keep our needle of the compass over here, have radius is equal to this length or this length. So with this as the center point, one arc will be drawn over here through these 2 points over here. Similarly, with this as the center, radius of the arc equal to this much or radius of the arc equal to this much. So with this as our needle point, radius is equal to this. Again, another arc we are going to draw over here. This is our second arc. Then this is our third arc center point. So with this as our center point or the needle point of the compass, we'll open the compass equal to this radius or this radius. Again, one more arc we are going to draw over here. And finally, this is our 4th center point. So from the 4th center point again, this will be our radius or this will be our radius. So keeping needle point of the compass here, we'll draw an arc into this orientation. So using these 4 centers, we have been able to obtain 4 arcs, and into the isometric projections now we can see an elliptical construction we have been able to obtain, which is going to represent a circular hole corresponding to 40 millimeter diameter, which is located centrally through these 2 horizontal webs which we have obtained over here. So now the circular hole we have been able to obtain. Let us join the remaining portion of the solid which will be visible to the observer. So we know that element number 2, it happens to be a square web having vertical walls or vertical edges over here. Now we can see we can join the top face. So this face will be visible to the observer. Then we can join the vertical walls and the base of this element number 2. So this is the complete element number 2 which will be visible to the observer. So we can check, we have used different colors over here. Black one to represent the circular hole, blue one to represent the second element or the second horizontal web which is going to lie onto the top face, and over here now we know that a different color we are going to use. But one thing more we need to remember. So into this top surface of this bottom horizontal web, we observe that there are inclined surfaces which are going to start from this point to the bottom extreme point over here. What is the location of this point? This is 20 millimeter from this side, 20 millimeter from this side. Similarly, this portion is again 20 and 20. This portion is also 20 and 20. And this portion will also be 20 and 20. That is, from these points, we can see from these points, we have to join this point with this point. We have to join this point with this point. And we have to join this point with this point, so that these 1, 2, 3, 4, 5, 6, 7, 8. These points they can be located, but we can see 7th and 8th point we are not able to see into the isometric projection over here, because this portion of the lower web has been covered by element number 2. So these three inclined portions corresponding to the horizontal web number 1 we have to plot over here. So now we can check 20 from this side, 20 from this side, 20 millimeter from this side, 20 millimeter from this side we have plotted, 20 millimeter from this side and 20 millimeter from this side. Now the top portions corresponding to this point we have been able to obtain. At the bottom where we need to join this inclined edge, we have to join this inclined edge at a point 100 millimeter. You can check. This distance has to be 100 millimeter on either side. So the top will be available 20 millimeter from the corner, whereas the bottom has to be located over here. Bottom has to be located over here. Bottom has to be located over here. So now let us join face number 1 corresponding to the front face, face number 2 corresponding to the right hand side view face, and one more thing, that is this portion of the solid will be visible. I can join this portion, I can join this portion, and now corresponding to the inclined base, this portion and this portion of the base I also need to join. So once we join this portion of the base and this portion of the base, so the isometric projection construction corresponding to the bottom horizontal wave, the top horizontal wave and the circular hole can be completed over here. So this way we have been able to evaluate the 3D isometric projections corresponding to this engineering object, which is comprising of two elements. A bottom element, which is a horizontal wave having 4 inclined surfaces at its ends over here, whereas element number 2, it was a square wave having vertical edges over here. We can check. Element number 2 is having vertical edges, whereas element number 1, it is having inclined edges, where at the top 60 millimeter will be the width of the edge and at the bottom 100 millimeter will be the width of the edge. And finally we have been able to obtain a circular hole on top of this particular element number 2, and since the hidden lines they are not projected in the isometric projections, so we haven't shown the hole which is not visible to the observer into the isometric projections over here. So this way we have been able to convert the information which was available with us through the orthographic front view and the top view projections into a single 3D isometric projection view, into which the front view face, the right hand side view face and the top view face, all these three faces, they have been combined into the 3D isometric projection construction over here. So this is all for today. We will be continuing with further discussion regarding few more illustrative cases of isometric projections in the coming lectures. So thank you very much. Thanks a lot.